statistics in R. There are many statistics functions that can be used in R easily. Some of them are mean, standard deviation function, calculating variance, calculating minimum value, maximum value, median, range of values. We can calculate quantiles, summary of the data set, row columns and row sums and column sums, and row means and column means. So let's start with mean values. For doing descriptive statistics, I'm using dataset empty class, the inbuilt dataset. So first we will be calculating mean value for the MPGs, for the MPG value in the empty car dataset. For that, the function is mean within brackets, name of the dataset along with the column name for which you are calculating the mean. Let's execute this command. And you can see the mean value for MPG column of empty cars dataset is 20.09. Similarly, if you want to calculate median, for that the function is median within brackets, name of the dataset along with the column name. It can be a different column, like I am taking MPG here. You can take other columns as well. Let's execute this command. So it is 19.2. Then we can calculate variance. For calculating variance, so variance is the value. Variance is the value which tells us how far our data is spread out. So let's execute this command. For that we are using VAR. The function name is VAR for variance. Within brackets, name of the dataset along with MPG. If there is any issue or any error that can be occurred with the formula, or you want to understand any of the function, you just question mark it along with the name of the function and you will get the help for your desired function. As you can see, variance, covariance, correlation, you can calculate each of the statistic function here, and whole of the formula is given to you. Like first is the dataset name, then if there is any random number, if you want it to be true or false. Similarly for covariance and correlation of the data. Now if you want to calculate the standard deviation, so for that formula is SD. Within brackets, the dataset name and the column name. Let's execute the command. So SD of this column and empty cars dataset is 6.02. So it tells that how far the data is spread out in comparison to the mean value of that data set of that column, like MPG here. If you want to compute the minimum value, so we are calculating finding out the minimum value in MPG column of the empty cars data set. So it is 10.4. Similarly, if you want to calculate the maximum value, it is 33.9. The range of the column in empty car data set, so the formula for that is range. And you can see the range of MPG values starts from 10.4 and the highest value is 33.9. Generic functions include the summary of the column of MPG. So if we execute this command, so you can see we get minimum value, maximum value, first quantile, third quantile, mean and median of that column. So what is quantile? Quantile actually is the portion of the data set, the value of that data set. So here the first quantile tells you the middle value between minimum and the median value of the data set. Similarly, the third quantiles tell you the the difference between the center and the maximum value of that data set. So we are generally what it is said is there is 4 quantiles. There are 4 portions of whole data set. It is equal to 100%. So it is first quantile, second quantile, third quantile, and fourth quantile. Next is we are calculating the quantile itself for MPG column, where we are taking a sequence probability starting from 0 and 1, having a gap of 0.25. So what we does is we calculated the 4 portions, different quantile probabilities. So it is the first value starting, that is 10.4, that was the minimum value. Then the first 25% of the data set, so it is the difference between minimum and the 50% data set, it is 15.425. Similarly, the mean, it is the median value. Also, you can say 50% is the median value. Then there is third quantile, which is the difference between 50% and 100% data. And last, it is the maximum value of the data set. Next, calculating row sum and column sum. For that, I am creating a data frame here. Data frame having two vectors A and B with numeric values. Let's print this vector. So these are the values of the data frame. Now what we want is we want the column sum of data frame. So column sum A and B. For that, the formula is call sum, wherein S should be capital. Call sum, it will give you the result with the sum of columns in the data set DF. So you can see there were two columns A and B. The sum of columns is printed here. Similarly, if you want row sum, the function is row sum with capital S for the sums of the data set. So you can see it is printed in the form of vector, but it is the sum of each row of the data frame that we just created. Similarly, if you want to calculate column means, so it is call means with capital M in the formula and within brackets name of the data frame. So the mean of A column is 4 and B column is 4.428. For row means the function is row, capital N means within bracket name of the data frame. So you can see, and there is mean of each and every row of the data frame. So we have calculated different descriptive statistic functions in R: mean, median, variance, standard deviation, minimum, maximum, range, summary of the data set, quantiles, and column sum, row sum, and column means and row means. Apply functions or apply family in R. Apply family is a very helpful time-consuming function in R. It helps to subset the data from matrices, arrays, lists, and data frames in a repetitive way and do statistical summary of the data. It avoids making loop functions which are very time-consuming and makes analysis complex. So apply family is very helpful as it saves our time from avoiding our loop functions which are very time-consuming, and they create a long functions which complexes our data. There are many types of apply family functions there. Some of them are apply, lapply, slapply, mapply, and tapply functions. So let's start with apply function first. Apply function operates on arrays or data frames or matrices and returns vectors or list of values in return. The function that we use for apply is apply within the brackets x, then comma margin, then comma function. So what it says is apply the function to the column or row, which is the margin here, and x is the data frame on which our function will be applied. Let's go to R and check how to apply this function. So if you want to check about any function or any package, so what is the help that you can do is whenever you want help of regarding any data or data type or data set, you just have to put a question mark and write the name of the data set or the function. It will help you out. Like I have executed this command question mark apply. So you can see their help is provided from the R with all the data about R function. So you can see apply function, what it says is returns a vector or array or list values obtained by applying a function to margin of an array or matrix. So let's build a data frame first. So what I'm doing is I'm taking a variable df and making a data frame in it with command data.frame. Within brackets, I'm taking two columns, that is first and second. In first, I am taking numbers from 1 to 10, and in second column, I am taking numbers from 11 to 20. Let's execute this command and check the values of df. So you can see we have two variables, first and second, with values in first from 1 to 10 and in second 11 to 20. Now let's apply function in it. What I want from this data, I am taking second margin. So second here means the column margin. I want mean of the second column from the df data. So my function is apply. Within the brackets, I am taking the data frame, that is df, comma the margin. So margin, if you want to take row, here it will be 1. If you want to take column, it will be 2. After that, the function name. So your function can be mean, it can be median, It can be standard deviation, it can be minimum, maximum. Any statistical function that you want to apply here, you can write the name of that function. So I'm executing this command. Sorry, I haven't applied it to hold the function. Let's execute the whole command. So you can see what happened is I got mean of both the columns because I have taken 2 here, which means I want mean of the columns, each column. If I would have taken 1, like in next command, I have taken 1 here, which means I want to have mean for each and every row. Let's execute. So you can see for each row, mean has been resulted. So there were 10 rows and there are 10 values. Next, what I'm doing is I'm sorting the data. Now, what is sorting the data? I'll create a database, data frame, and from that data, we'll apply function, apply and find out the column sums, row sums, and then we'll sort the data. So first, let's combine 2 columns. So I am using cbind, that is combining columns. Within the bracket, I am taking first column as x1 with value. So we have taken the formula cbind, within which we have taken x1 equal to 3, which means the values in this column will be equal to 3. Next is x2 column, in which I am taking 2 things, 4 to 1 and 2 to 5. So what it means is, first it will create a vector x2 in which there will be values of x2 1 initially, then there will be 2 to 5. Let's execute this command. These 2 vectors will be combined with the help of the formula cbind. Let's check the value of x. So you can see there are 2 columns, x1 and x2, and values have been saved in them. How do I know that what my values have been saved? So 4 to 1, you can see in column 2, 4, 3, 2, 1. Then there is 2 to 5, then there is 2, 3, 4, 5. So this is how my x variable has been formed. Next, I am giving the dimension names. So now what I am doing is, I have already given the column names as x1 and x2. Now I am giving names to the rows. Here you can see it is 1, 2, 3, 4, 5, 6. It is before the comma, which means it is row number here. So what I am doing is, I am saying dimension name of x. In the x data, dimension names, I want to put letters from 1 to 8. As you can see, there are 8 rows. So I am taking letters 1 to 8. So you can see here, there are double brackets and within which it is written as 1. So it means they are indexing. What I am doing here is, I am indexing the value. So I am saying rows here. In the x data set, only row names I need to put, in which I am putting letters from 1 to 8, letters A, B, C, D, E, F, G. So let's execute this command and now check the values of, as you can see, 8 of the letters have been printed here. Now I am executing this command and giving dimensions name. Now x1, x2 are the column names and A, B, C, D, E, F, G, H are the row names. Now what I am doing is, I am putting the function apply in dataset x. 2 here means the margin. So margin, it means column here because I have taken 2 as margin. So I have help here. You can see I have taken, let's do question mark apply. If you don't know how to use the formula, just do question mark apply and you can see you will be having the formula here. So you have margin and you then need to put function. So I am giving margin as 2, that is columns, then function, that is fun, equal to mean. So I want mean of each column in data set x. So you can see for column 1, mean is 3, for column 2, mean is 3. Next, let's find out the column sums. So I'm saving the values in column dot sums and applying the function. Similarly, like earlier, I put mean here. Now I am putting sum here. And let's check the value of column sums. So what happens is, the value of first column, the sum of this column is 24. Next, the sum of column number x2 is 24 again. Similarly, row sums. So you can see we have the sum of each of the columns here. Now what we are doing is, we are sorting it. So what I am trying to do is, I am showing you different types of functions that you can put in this apply function and do the statistical analysis. So I am giving apply function here. Again, to the X data set for columns and sorting it. So let's execute this command. Now what happens? You can see earlier my data set was 43212345 in X2 column. Now what I told in this function is sort the X data set in according to columns. So we have sorted the columns and it became 1 2 2 3 3 4 4 5. Next function is lapply. Next is lapply. So what does lapply do? It is used for other objects like data frames, lists or vectors. Similarly, when you want to apply function, the data type it takes is in the form of data structure is data frames, list, vectors, and it returns list. So earlier what apply was doing is it was returning both vectors and lists, but in lapply the return will only be in the form of list, and the function to be used is lapply within the brackets x and function. Let's understand the function. X here means the vector or an object. So it is the data set basically that you are going to enter here, and function which you want to apply of each of the element of X. So I have also given an example here, as you can see, lapply. So I'll tell you how to get this command and how to get this output. What does it mean? Let's go to R and create an example. So I'm creating a data frame here where three types of data types are there. So first is matrix, second is matrix, and third is data frame. Let's create a matrix. How I am creating it? I am taking 9 values using matrix command. Within bracket 1 to 9 values, n rows 3. So I'm taking 3 rows and I'm filling it by columns. Let's execute it and let's see what happens. So you can see there is an output in which I have 3 columns, 1 to 9 values filled in column form. Next, I'm taking a matrix with 4 rows, same way. So you can see 4 to 15 values are filled here. Next is a data frame with 2 variables x and y having similar value of 8, 9, 10. Let's execute this command also. Now I'm creating a list out of it. So I'm saving it in my list. The function I'm using here is list. Within the brackets, name of the variables that I have created. Let's execute this command and my list. So you can see there is a list of 2 matrix and a data frame. All are in their own data structures. Now let's apply lapply function. So lapply within the brackets my list, that is the name of the data set I am using here that I just created. After that I am giving a operator, that is a selection operator. So in this you have to give a function as we have discussed. So here the function is selector operator. And after that I am saying I want to extract the second column from my list with the selection operator. So I have already given the selection operator here. After that because I don't want any rows, particular row, I need the second column from each of the data structure. So let's execute this command. So you can see what happened. My data set was this. I had one matrix, then the other matrix and a data frame. I extracted second column of each of the data set. You can see 4, 5, 6, 8, 9, 10, 11 and 8, 9, 10. So second column of each matrix and data frame. Next is how to extract the first row from my list. So I am extracting first row. Similarly, earlier I extracted the second column. Now I am extracting first row of each of the matrix. Let's execute this command and you can see what happened is this was the matrix, whole matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, 4, 7, similar way. Now I wanted only first row 4, 7, 1, 4, 7, 4, 8, 12 and 1, 8, 8. So how do I know it is the same? So you can see 1, 4, 7, 4, 8, 12. So it is the first row of each of the data structure. Next, I want a single element for each matrix from my list. Now, earlier what I did is I extracted a single column from each of the matrices. Then I extracted first row from each of the data set my list. Now I want a single element of each of the matrix. So I am giving first row and second column here. Again, the function is selecting operator. Let's execute this command. Now the element present at this position, that is first row and second column. Let's go to our data set. So you can see this is our data set. First row and second column, the value is 4. Similarly, first row, second column, the value is 8. And first row, second column, the value is 8. Let's see our output. It is the same. So 4, 8, 8. So this is how Lapply is used, and its output is always in the list form. Similarly, one more example is there. There are movie names here, that is Spider-Man, Batman, Vertigo, Chinatown. Now I want to convert it into lowercase. The formula same Lapply will be applied here. First is movies, that is the name of the vector I have used here, and function is to lower. So what I'm doing is I'm converting these names into lowercase. Let's execute. Oh, sorry, I didn't execute this vector. So movies. Then let's check the values of this variable. So you can see it is in the form of list. First, it was Spider-Man, Batman, Vertigo. They were in uppercase and have been converted into lowercase. Let's go to our slide. Next is sapply. Now what is sapply function? It works similar to lapply, but major difference in lapply and sapply is lapply returns list in its output. Sapply returns a vector when the function is applied. So it simplifies our output. It do not clutters. It is also called as a wrapper function to lapply. And the function that we use for sapply is sapply within the brackets. It is x comma function. So x here is the vector or the object that we are using to convert. Next function. Function is applied to each of the elements. Let's go to R and let's create our data set. So we are already having our data set, my list, and I am applying the same function on the same data set. We have already applied lapply on my list. So I am extracting the values from first row and first column of my list using lapply function and saving it in a variable. Let's execute this command. If you see if there is any error in the console area, what you can do is just go to that area and press escape. It will give you a new line and you can execute a command again. So I am executing my command again. I am saving lapply result in A. Let's check the value of A now. So you can see I have first row, first column value in from each of the matrices. Now I am applying sapply function. Sapply function, what it will do is it will return the same values 1, 4, 8, but in the form of vector. So lapply returns list, sapply will return vector. It is the same format. Let's check its value. So you can see I have again got first row, first column's value, but in the form of vector here. Now let's go to tapply. It is the next apply function, tapply. So tapply is used to create subsets of a vector and use those subsets and apply measure functions to each of the subset. So we can compute mean, median, mode, minimum, maximum, or a function for each factor variable in a vector. The function that is used is x, comma index, comma function. So here x is the vector or the object that you are using for your as a data set. Index is the factor variable. So let me explain how tapply works actually. Tapply helps us to build a function where we will be taking in consideration a categorical or a factorial data and finding a function mean or any of the function that you will apply from that data set. Let's go to R and make it easy for you. To explain tapply, I'm using a data set empty cars. It is a inbuilt data set. We have used it earlier also. So in empty cars, Let's check the names of the cars here. What are the variables present in empty cars? So it is mpg, miles per gallon, cylinder, displacement, horsepower, weight, and etc. All the names of the variables. Now what I am doing is I will be extracting a categorical element from this empty car data set, and I'll be taking mean of MPG based upon that categorical data. For example, let's say we have a data from our superior, wherein, taking this example only, we have MPG values with us, and our superior gives the transmission values or cylinder values later on and tells us to calculate the mean of the MPG based upon the transmission or cylinder values that he has provided later on. So what we'll do is we'll extract the data from empty cars. So what I am doing is I am subsetting it. To subset a data, we used square brackets and extract a column or row, whichever you want for your analysis. So I am creating a variable AM1 and I am saving the AM, that is automatic transmission, from the empty car dataset. So from empty cars, I want subset. So I'm using square brackets here, as you can see. Then there is comma. So I want all the rows. So I haven't taken any value before comma. After that, I'm taking AM in inverted commas, which will give all the values in that column, AM column, in AM1. Let's execute this command. Next, I have created a variable CYL, that is AM and cylinder. So again, it is same. From empty cars dataset, I am subsetting cylinders and AM transmission into this variable. Next is MPG. Similarly, I am taking MPG in a different variable. Now I'll apply the function tapply. You can see AM and cylinder is a categorical value. How can you know that? Let's check the data set. So what does this command do? Head means it will return first 6 values of the data set. Okay, so we have name of the cars here, their MPG, cylinder, and other values. Now you can see AM is a factorial data or a categorical data. Similarly, cylinder is also a categorical data, and we will be calculating mean of MPG based upon AM, and AM and cylinder both. So tapply, within the brackets I'm taking MPG values. After that I'm giving AM. So now my index here is AM. Let's check what is tapply. Will be helpful for you. So what we are doing is we are giving the dataset name. So first, what vector or whatever values you want to calculate your mean for. So I want MPG here, so I am putting MPG. Then index. So index is the categorical or factorial value. So here I am taking AM, that is the transmission. So for 1, here you can see in the dataset it is 1 or 0. So 1 means it is automatic, 0 means it is manual. Next, mean. So I am taking mean of MPG based upon this index value. Let's execute this command. So this error was given here. So it was saying MPG was not found because I haven't created that vector earlier. So I executed that command now and giving the function. So you can see the mean value of MPG, that is 17.147, based upon the automatic transmission. So there are 2 types of transmission, that is manual and automatic. And similarly, you can do it for cylinder. Let's execute this command. So you can see in this variable we have cylinder and AM both, and I'm taking mean values. So you can see there were 3 types of cylinders and 2 types of automatic transmission, 4, 6, 8 cylinder, number of cylinders, and 0 and 1 manual and AM transmission. So it is giving the value of mean MPG based upon 4 cylinders, and if it is manual or not. If it is manual transmission and 4 cylinders, the mean value of MPG is 22.9, and similarly other values are also calculated. Now let's go to next slide. Next function is rep function. What does rep function do? It replicates the elements of vectors and lists. So it is a helpful function in a way that it helps to create a matrix very easily, as it repeats the data in your data set the times in which you want. It should be an integer value vector. So let's go and create a new vector using rep command. So I have already created a value here. You can see I created a z value variable in which I got first row and first column values from my list data structure here. From this my list, let's execute this. So this was my data set where I got 3 matrices, out of which I have taken the values of first row and first column in the z variable. I'll copy this command and put it here so that it is easy to understand. So I am applying apply function to my list dataset and getting the value of first row and first column. Let's execute this command and check the values of z. So the values of z are 1, 4 and 8. Now using rep command, what I'm doing is I'm giving the vector name that I want to repeat. So my vector is this 148 and it is 3, 1, 2. So what will happen is it will repeat 1 3 times, 4 1 time and next value 2 times. Let's execute this command and let's check the value of a. So you can see my values of z as per my formula which I put was 148. Now I wanted 3, 1 and 2 times the value of z. So 1 has been repeated 3 times, 4 1 time and 8 2 times. So it is a short formula, you can say, which helps us to repeat the values and create a vector or create matrices easily. Next is mapply. It is the last function that we will be covering. So mapply stands for multivariate apply function. It is able to vectorize arguments to a function that is not usually accepting vectors as arguments. So mapply is a function that helps applies function to first element of each argument, then second, then third, and so on. Let's go to the R and easily understand what it means. Similarly, as we have got help for other apply functions, you can similarly get help for mapply also. So what I'm doing is I'm creating a matrix here and saving it in Q variable using matrix command. So I am combining these values. So what it is doing is it will repeat 1. So it will repeat 1 4 times, 2 4 times, then 3 4 times and 4 4 times. So repeat command says the first one is the value or variable that you want to repeat and second is the times, how many times you want to repeat it. And I am using matrix command here, so that is 1 2 3 4 commands. Then I'm saying 4 columns and 4 rows here. So let's execute this command and let's check its value. So you can see I have a easily created matrix with value of 1 repeated itself 4 times and similarly 2 3 and 4. Now I am applying mapply function to it to easily create this matrix without using matrix command. Now I am saving it in p variable, applying mapply function within brackets rep. So first I am giving the function name that I want for each of our variable. Like earlier we are giving the function at the end of the command, but in mapply first we are giving the name function here that we want to apply to our matrix or the values. Next, I want 1 to 4 functions to be repeated 4 times. So if you can understand this command, mapply does is giving the function rep, that is repeat 1 to 4 times. Let's execute this command and check p value. So you can see it is the similar function, similar matrix that has been created, but using mapply function. Similarly, you can also do is I'm giving one more command to tell how to apply this function using other functions. So mapply within the brackets sum. So now I'm using the function sum here and I am taking 1 to 4, 1 to 4, 1 to 4. So what does it mean? What this function will do? Let's execute this command first and check what happens. So you can see there is 3, 6, 9, 12. So how does this number came? What will it will sum up the value of 1 3 times. We are giving these values 3 times. So what will it do is, it will sum up 1 3 times, then number 2 3 times, then number 4 3 times. So if you are able to understand what it is doing is 1 plus 1 plus 1, 2 plus 2 plus 2, 3 plus 3 plus 3, and 4 plus 4 plus 4. Easily we can sum up these values using apply function. So we have covered the apply family functions using the different functions. We have covered apply, L apply, S apply, T apply, M apply, and a rep function, to make you understand how apply functions are used and how are they helpful to save time and avoid making loop functions, which makes our analysis very complex. So now I'm taking one more example for the aggregation of the data. For that, it is a Excel file that I have created. For reading a Excel file, the library that I'm using is XLSX. So let's load this library. If you don't have this library, then you have to install it. Then you will be able to run this in your session. Now I am taking a variable name, that is add. The command that I'm using is read.xlsx. Within the bracket, I'm giving the name of the file and the sheet name. So it is the first sheet of my Excel file. So I'm giving 1 here. If it is second sheet, third sheet, you can name it accordingly. So let's execute it. And now let's check the variable. So this was the data that was in the file. So there is name of different people. There are 10 people. Then there are roles, each of the people that they are designated to. So there is cook, there is server, then there is a manager. Then there is shift. There are 2 types of shift, lunch and dinner. Then there are salaries and ages. Let's aggregate the data now. So we are finding mean salary expenditure based on shifts. So we will be finding the mean of the salaries based on shifts. So for that we are using aggregate command. Within the bracket, first is the data that you want your mean for. So I want mean for salary. So I'm providing that object. Then the by parameter. So by parameter is the subsetting parameter. Here it is the shift for which I am calculating mean salary. So it is shift. I have taken shift as the name of the column. So I have assigned name to this column. Then the function I'm using is mean. So let's execute it. So you can see, and there were 2 shifts, dinner and lunch, and there is mean salary per shift. Then we are aggregating salary based on roles. So the salary is same because it is the main data on which we are using our function. Then the parameter is role here. I am not assigning any name. So you will see the change. The function I'm using here is mean. So the column name has not been updated. It is taken as group 1. If I have given role name here, so you can see the name of the role has been, the name of the column has been updated to role. So the result which it says is cook is the mean average salary, the mean salary of cook is 1500. It is taken as with calculating for 2 shifts. There are 2 shifts, as we know. So the cook are in first shift, that is lunch also and dinner also. So it is a mean salary for both the shifts. For the role of cook, for the role of manager, it is 2100, and similarly for server, it is 1500. Then aggregating salary based on the role and shift both. So the function is same, taking salary here, then the list of parameters that you want for your subsetting data set, then the function is mean. So there was group 1, that is the role. So you can name it as role. Then there was shift. So I'm taking shift here. So as per cook on dinner, the mean salary is 18. Then manager for dinner shift, the salary is 2000. Similarly, all the values have been created. Now let's go to table functions. So we will be covering 4 types of table functions. First one is table, which performs categorical tabulation of data with the variable and its frequencies. So table command helps us to get a categorical or a tabulation of the data set wherein we will be able to find the counts or the numbers of the variables. Then there is add margins. extend the table with the marginal totals of the rows and columns. So with using add margins, we will be able to take the totals of rows and columns and add it to our table. Then there is margin dot table, which helps us to calculate the value of overall tables. Like if you want the sum of whole table, you can use margin dot table for that, or if you want row wise totals or column wise totals, you can use margin dot table for that. Then there is prop dot table. So prop dot table computes proportions, so it converts your frequency table, that was the categorical tabulation, into the proportions. So let's go to R and create the commands for table. So first we are using the table command, and the data set I'm using here is empty cars, which is the inbuilt data set. If you want to check the structure of empty cars, there are 11 variables and 32 rows in this data set. So let's calculate the categorical tabulation of cylinders. So cylinders for empty cars, we will be calculating a tabulation wherein we will be getting the number of cylinders in the empty cars data set and the total of cars. If you execute this command, the function is table here. Within the brackets, the column or the variable that you want to calculate your table for. So here I have taken cylinders. So there are three types of cylinders in empty car data set: 4, 6 and 8. And 11, 7, 14 represents the number of cars having each of the cylinders. So there are 11 cars with 4 cylinders, then 7 cars with 6 cylinders, 14 cars with 8 cylinders. Similarly, if you want a table with cylinder and gears, so let's execute this command. So you can see there is no naming to the rows and columns, so it will be difficult to interpret which are the columns and which are the cylinders here, cylinders and gears here. So what we will do is we will add one more operator here, that is D and N, which means the dimension names. So we will be giving dimension names as cylinder and gear. So let's execute it. So you can see the columns are the cylinder, and the each row represents the cylinder and each column represents the gears. So there are 3 geared cars, 4 geared cars and 5 geared cars, and cylinders 4, 6, 8. So there is 1 car with 4 cylinders and 3 gears, 8 cars with 4 cylinders and 4 gears, and similarly whole table has been created. Next, what I'm doing is I'm saving this data into a variable T1 for the further analysis. If you want to check the data, it is the same data set that we created. Now we are using the command margin.table. So if you are able to understand table command help us to create a categorical tabulation of the variables in the data set. Whenever you want a count of any of the variable, you can use table command. Similarly, now we are using margin.table. So it will help us to calculate the total sum of tables or margin wise totals. So first what we are doing is we are doing sum of whole table. Let's execute this command, the margin.table. Within the bracket, I am giving the name of the table that we created with table command. So you can see the total of this data set that we created here using gear and cylinders. So the numbers, they are the cars representing with each cylinder and gear. So as we know, there are 32 observations. So the total number of cars are represented here are 32. So it is sum of the table. Then there is margin.table. First we are taking the object or the data set that we are using. So here we are using this data set. Out of that I am using margin 1. So when I specify margins, so I am saying margin 1 here, it means take the sum of each of the row. So and there will be sum of each of the cylinders. Total cars having 4 cylinders, total cars having 6 cylinders, and total cars having 8 cylinders. Let's execute and check the output. So you see there are 11 cars with 4 cylinders. If you want to recheck it, the 8 plus 2 is 10 and 11. Then 4 plus 2 is 6 and 7 with 6 cylinders. Then 12 and 2 is 14 with 8 cylinders. So it is row wise sum up of the table. Similarly, if you give margin as 2, it will calculate the column sum, that is the gear wise total. So there are 15 cars with 3 gears, 12 cars with 4 gears, and 5 cars with 5 gears. Then you can also add mean function to it. And the next function we are using add margins, which helps us to extend a table with margin totals of rows and columns. So we will be using functions to calculate the sums or means of the rows and columns, and then we will be adding it to our table. So first, add margin, what will it do is, so here it is the, we are giving the name of the table that I am using, which we created using table function and substituted with cylinders and gears. This was the table that I am using. Then I am using margin 1. So what I want is default is, if you do not give any of the function, the default function that is used is sum of each column shown as row. So each column will be summed up and a row will be added here. Let's execute this command, and you can see and the total of each of the column is added in the form of a new row to our table. Similarly, if you add a function, you can, if you change the margin to 2, that is column wise, so one more column will be added here, giving the sum of the cylinders. So function that we are using here is mean. So the mean value will be added for each of the row. So you can see the mean has been added as a new column for each of the row. So because it is a decimal value, there are decimal values, so each of the other values have been converted into decimals. Then using add margins, again what we are doing is we are taking both of the margins now using combine function C and 1, 2, which means both row and column, and function I am using is sum. So now a row and a column will be added in one command for the sum of each of the row and column. So you see, sum of the rows has been mentioned here, and sum of rows columns is mentioned here, and it is the 32 is the total of the whole table. Then you can also use two functions at a time. So for this, what will happen if you are giving margin, taking both margins 1 and 2, that is row and column, the function as you specify, it will be used respectively. Like if you give sum and mean, so sum will be for the row part and mean is for the column part. So if you can analyze the data that we used here, and the mean has been calculated for the rows, that is for the cylinders, and sum has been calculated for each of the columns, that is for the gears. Then next is different functions in rows and columns. So what we will be doing is we will be taking both row and column, and the function we are giving as list here, because for row we are using different functions, then for the column we are using different functions. So if you want to specify different functions for both margins, you have to use list command for that. Using list, all these functions will be applied to row, and SD and sum will be applied to column. Let's execute this command, and you can see the output. Standard deviation and sum has been calculated for cylinder values here. And if you want to check for the column or the gear part, there were 4 functions that we used. So we have mentioned mean twice here, so we can remove it. So there are 3 functions now: sum, mean, and length. So for gear, these are the functions used for gear, and 2 functions used for column rows. The last is prop.table. It converts a frequency table to the proportions. So how do we calculate it? So this was our table that we are using for analysis. Now we will be giving the command prop.table. So prop.table will convert these values, that is 182, 241, 1202, to proportions. Proportions means in probabilities. So you can see all the values has been converted to proportions of the whole table. So how it's calculated, that this is 0.03125. So the total of this table was 32. If you remember, it is 32. Then the value of 1 here. So That means one car with 4 cylinders and 3 gears. So 1 will be divided by 32. Let's execute it. So the value you see here is 0. So this part is the first proportion of whole table. So the next value was 8. So 8 divided by 32. Let's see what is the result. So you can see it is 0.25, which is the second value of the table. Similarly, whole of the table is calculated, and this the fact of this output should be like when you total the whole table, it should come out to be 1, which means 100%, because 1 is being divided into different proportions based upon the values for each of the element or position. Next, what we are doing is we are summing up based upon the margins. So we are using prop.table here. Then there is the name of the table that we are using, then margin is 1. So it will sum up each of the rows. So now you see we have what you have done is we have taken margin 1 here to calculate sum of each row. So what does it show? You see the values has been changed. So what does it show? So the cylinder 4 and gear 3 values. So this was our table. The total of this row was 11. There are 11 cars with 4 cylinders. Now what we asked for it was for each row what is the total, and the table has been proportionately divided based upon the total of the row. So the sum of the row is 11. So for first value here, which is 0.09, you can see here. So 1 divided by 11. This was the first position, first element of this row, wherein the value is 1 here and the total of this row is 11. So this proportion is 1 by 11 of the table. So it is 0.0909. Similarly, if you want to calculate the second element of this row, you will divide 8 by 11. So you see, so they are the proportions based upon the total of the row. If you want to check for this row, the total was 4, 5, 6, 7. So if you calculate 1, 2 divided by 7, so the value should be 0.285. So you see it is the proportion of first proportion of the total of this row. Similarly, if you want column wise, you will change the margin to 2. So the sum of this row, sum of this column was 12, 13, 14, 15. So you, 1 of 15. So the value of 1 by 15 will be 0.666, which is the first value of this column. Similarly, if you want to calculate the second element of this column, you will be dividing 2 by 15. So you can see the value matches. So whenever you are taking row wise sum, the sum up of this row should come out to be 1, or if you are taking column wise, the sum up of first columns should be, each column should be equal to 1. Now creating a matrix using prop.table and adding percentage sign to it. Now you will see, you see there are different. So let's print the value of proportion.table. So this was the original values when we created the table in the form of proportions. Now we will be adding a percentage sign to it after getting a round of values. So we are creating a matrix. So what we are doing is we are using the formula inside the bracket using the function paste. So what does paste do? Paste will use the values of this function, attach it with percentage sign and the separator that you will be giving. And because I'm converting it to a matrix, so I'm giving the number of columns here as 3. So within paste, first thing I'm giving the values. The values is given by the function prop.table, wherein the table is T1. Into 100 will convert it to a round of values, then adding percentage sign to it with a separator, and will be divided into 3 columns, 3 rows. Let's execute it. So you see there is the value was earlier, it was when the table was in proportionate form, it was 0.03125. Now it is 3.125 because we have multiplied it with 100 and added a percentage sign to it. What I am doing in this function is I am doing a quick check whether the proportion table it's giving me correct output or not. For that, I'm using row sums and taking the function inside the row sums, that is proportionate dot table, that is prop dot table. Within the bracket, I am saying the row sum convert the table to proportions using margin 1. So according to sum of rows, the values come out to be 1. As I told you, the sum of each column or each row should come out to be 1. We are confirming it same way using row sums or column sums. So the tables function and aggregate functions are very basic but are essential functions which help us to understand the data with with efficient statistical analysis and making the data more interactive. Data manipulation in R using DPLYR package. So DPLYR package is a grammar of data manipulation. It enables efficient manipulation of data with advantages of speed and simplicity of coding. So DPLYR is the package which helps manipulate data using available set of variables. It helps in enhancing the accuracy and precision of the data we are using. It is also known as data wrangling or data cleaning. So when we use DPLYR package for manipulation, there is an operator that helps us to provide the formulas or functions to our data set. So it is called as the pipe operator. It is percentage sign, then the greater sign and the percentage sign. So it creates a pipe symbol or the pipe operator which passes data from the output of the function to the left and puts it by default into the first parameter of the function on the right. So if, for example, we are taking a data set and we are giving a piping operator, so the function provided here will be operated using the data set and the subset we have created using the function on the right. So the functions in DPLYR are summarize, mutate, select, filter, and arrange. These all combine naturally with group by function, which allows you to perform any operations by groups. So you can always summarize or select or filter your data using a group or conditions using DPLYR package. So let's first understand each of the function. So first is select. It is used to select variables that are columns. The function that is used in R is select function, which helps to select the column based on the conditions we will be providing. Next is filter. So it returns all the rows that satisfy a following condition. So the condition we will be providing, it will be returning rows as a result. Generally, it is used with relational or logical operators. Function that is used in R is filter, which filters the row based on the condition. So next is summarize. Summarize it summarizes multiple values into a single value, which means the summaries are calculated by grouping observations using a factor or a categorical variable first. So whenever you want to calculate mean of your variables or the sum or maximum, any function that you want to summarize statistically, you can use summarize function for that. It gives best result when used along with the group by command. Next is mutate. What does mutate means? It adds a new variable and preserves the existing one. So if you want a new column to be added to your data set, it will help you to add a new variable or a new column, provided you already have some data with you, and based on that data it will create a new column, mutate command. Then next is arrange. It helps to reorder rows by one or more variables. So we sort data into ascending order or descending order, and the function we use is arrange. So now let's go to R and create the commands. So the package that we are using here is DPLYR. If you are not having this data set, this package, so you can install it using package tab here, install DPLYR, or you can give the command install.packages to install the package name with DPLYR. So I already have this package. I am just loading it. You do not have to install it every time. You just need to load the command into your session whenever you are using that package. So the name of my package is dplyr, and the command vignet within the brackets name of the package name. It helps us to understand the package. So if I give this command vignet, so vignet helps you with the introduction of the package. So here there is introduction of dplyr. dplyr package makes these steps fast and easy by constraining your opinions. It helps us to think about data manipulation challenges. It is all about the package and the different formulas or functions we will be using in dplyr. So there is filter, arrange, select. It is about it will give you about each and every function that we will be using, some examples for that and the explanation for that. So let's load the library. So it says the following objects are masked from the package. Now we are going to start with our first function, that is select. For that I am using empty cars data package and I am copying all the empty car data variables into df variable. So we will be converting the relevant columns of empty cars into factors so that in further analysis and summarization we will be easily able to use factor variables. So for that I am first making a variable name, a vector with factor columns name, vector calls, and within that I am taking variable names as cylinder, transmission, then gear and carb. You can also take gear, cylinder here. It is also factorial value. We have already taken cylinder. So let's execute it. So now what we are doing is we are applying a lapply formula, which will say to the df call. So we have added this column to df using the. So we are subsetting our df data set. Df subset the call name. So we are subsetting this data set using this vector and applying lapply function and saying convert all these vector variables into factor into an ordered factor. So let's execute this command and check the values. So now let's check the structure of df. So you can see the factors that the variables that we took in our vector, that was cylinder, transmission, gear, car, that is carbonator, they have been converted into ordered factors. So there are two levels of VS. AM is of two levels, then gears are of 3 levels, cylinder is of 3 levels, and carbonators are of 6 levels. Let's go further. Now what we are doing is we are applying sapply function. What will it do? It will return a vector with different lists for checking the frequency of each of the factor column that we created. So it is a kind of table. Like cylinders, there are 4, 6, 8 type of cylinders and the total count of the cars for each of the cylinder. Similarly for transmission, for gear and carbonate. Similarly for carbonators. Now let's go to select function, how we use that. It is very simple to use select function. The function is select. Then first we are giving this name of data set. So here I have taken empty cars. You can take df here. The name of our data set was df, and mpg, that means we want to select all the mpg rows, mpg column from df data set. Let's execute it. So you see there are all the 32 rows for only mpg column. Similarly, if you want to select using piping operator, so I have taken the name of data structure here, the data frame. I can use df here, then giving the function select within the bracket the variable or the column that you want to select. Let's execute it. I have saved this in A. It is the same output that we got earlier. So it is the column mpg and the number of cars. So it is 32 observations here. Next, what we are doing is we are selecting mpg cylinder and am column from empty cars using piping operator here. Let's see the first 6 rows using head command. So you see we have selected. So what we are doing is we are actually subsetting our data data set using select command from dplyr package. So it is very useful and a quick and easy function to use whenever you want to subset your data. Then there is rename. So what does rename do? It changes column name and save it in same variable. So how does it, how can we use this? Suppose this is our data set that we are using V, wherein we have three columns, MPG, cylinder and AM, that is automatic and manual transmission. So what we want to do is we want to convert the heading into uppercase name. So for that, the rename function, how do we use it? So you give the name of the command, that is rename. Inside the bracket, first thing you will give is the old name or the new name that you want, then the old name that you want.